Okay, folks, this video is for the attention of a character called Red Pill Reloaded. Now, I had an interesting exchange with this character on YouTube, and well, I don't know if the guy's he or she is trolling me. I could be the victim of a prank, and if I am, well, round of applause to you for pulling a very good prank on me. But I'm going to give you the benefit of the doubt. So I'm going to assume you claim to be what you claim to be, which is a flat Earth believer. And you said in the comment on one of my videos that I said that it's impossible to have an eclipse on a flat Earth, and you claimed that wasn't true. You claimed that an eclipse on a flat Earth can happen, and I asked you to demonstrate how that can. I'm still waiting for that demonstration. Anyway, so I decided to upload a video strictly for your attention. This is aimed purely at you, right? So it doesn't matter whether I get 1 million hits or no hits, as long as you see it. That's all I care. Right. So let's start off with the globe model. Okay. Right. Now I'm pretty sure you know all this already, but again, I'll still go through it. So this is a very scaled down version of the sun. This is Mercury, this is Venus. I shall explain the relevance of these two planets in a minute. And this is the moon, it's the Earth, and these represent the cycles of the moon. This represents a lunar eclipse. Right, so how do we get an eclipse on the globe? It's when the moon is in between the sun and the Earth, and the shadow falls directly on the Earth below. Right, these arrows represent the direction of the light. As you can see, when the light goes across the Earth, and when the moon is in this position, and we get the lunar eclipse, and then you get the shadow of the Earth curve. Oops, going out of focus there. Of the Earth curve on the moon. This is something the ancient Greeks noticed about the curvature of the Earth shadow on the moon on a lunar eclipse. I've seen this with my own eyes. This was, I think, back in June 2019. I can't remember the date, but they predicted it down to the minute. Mainstream science, not flat Earth science, predicted exactly when this was going to take place. Right, and of course we have the moon cycles, the crescents and the full moon. Right. Okay, I shall come to this later. Right, so we'll just put this on the shelf for a minute, Venus and Mercury. Right, so now let's go over to the flat Earth model, which you claim can present a an eclipse. Right, so from what I've seen, this is the flat Earth model. This is the Earth, that's the sun, and that's the moon. Right, I could see a number of problems with this straight off. That doesn't coincide with reality. For starters, right? As you can see, this is the direction of the orbit by the arrows, right? So I've got to keep saying right. Anyway, I think this is coming out of focus. I'm not too sure. Right, I'll try and keep my hands steady as possible. Anyway, problem number one. The moon being opposite the sun at this angle would produce an all year round full moon. At this angle, you won't get no crescents. You like down here on the Earth, because the angle we're at, once the moon is in this position here, you'll just get the crescents and the moon cycle. This model doesn't matter where you place. Doesn't matter where you place the moon or where you place the sun, because they're opposite and they are on the outside of the rim of the flat Earth. You will always get a all year round full moon. The only way you're going to get a crescent, and this will add another problem. Okay, let's say you was to place the sun here, and you was to place the moon here. And you say, for example, now you got a crescent here. If you are based over here, right? Well, the other problem that will pose, which doesn't consort with reality, is let's say this is the United States of America here, and let's say this is Asia over here. Well, someone over here would see the moon at a completely different angle to someone over here. So if you're here, let's just for argument's sake call this nighttime, right? The person here will see a full moon. Person here will see a crescent on the same day. That doesn't happen in reality. So you've got that problem already. So you've got two problems: all year round full moon, or you've got the same moon on the same day, but two different types of moon: a full moon for one person and a crescent for another person. So straight away that falls to pieces immediately. And then as for the eclipse, as stated here, when the moon is in between the sun and the earth, hence you get the eclipse, the shadow. So please explain how and when would the moon at this angle get between the sun and the earth to form a perfect circle shadow, right? I keep saying right. I mean, so you're telling me what, the moon changes height? So it goes in a downward direction. So you would then, the light will come across this way, and then you get a shadow across like that, but the shadow will be elongated. It won't be a perfect circle like what we get here, right? So that's another problem. Another problem there. Well, you still have to explain how an eclipse actually takes place. Does it change height if they're orbiting each other? So when does this eclipse take place? How does an eclipse take place at this angle? Please explain. I'm intrigued to see how does it, and when according to this model, when is the next eclipse gonna happen? Right. So that's that. Now we come to Mercury and Venus. Now this is something I've witnessed with my own telescope with using a filter. I didn't witness it with Mercury, but with Venus, I witnessed the transit across the sun with my telescope via using a filter. I didn't watch the actual whole voyage from from right to left, but I still saw it when it was transit across. So, question: how and when does the planet Venus and Mercury transit across the flat Earth model? Right? Considering it's supposed to be a local sun and a local moon, so where is Venus and Mercury in this model? So when do they transit across in this direction? Do they transit across in this direction? That's another problem. So and coming back to the moon, as such, like I said, with this, you've got angles, whereas with the angles on the moon, when we see the full moon, the only difference in the angles is if you're in the northern hemisphere and you're southern hemisphere. Those on the southern hemisphere, the moon would appear upside down to us, and those who's on the northern hemisphere, the moon would seem upside down to those on the southern hemisphere. That's the only difference. But actually, in terms of degrees, we all see the moon at the same angle. So there's lots of problems you need to solve here with your so-called flat Earth model. So I would appreciate a video response. I mean, you could take the easy way out and give me links if you like, but I'm sure they'll be just as flawed as your opinion. I know she didn't get back to me, but anyway, still, there we are. So please explain. I mean, I've explained the globe easily, and the worst thing is I haven't even gone into time zones. I haven't even gone into the 6 month daylight on the poles. I mean, how do you get 6 months of daylight on here, and 6 months of nighttime on here. I mean, I can easily demonstrate how you can get 6 months of daylight on one pole while you're getting 5 months of nighttime on the other pole. I can easily explain that, and anybody could travel to the poles to witness this for themselves. A friend of mine, he's also a pro dancer. I think he went to Lapland or somewhere like that, and he was freaked out at the fact that it was it was midnight and it looked like it was 7 o'clock on a summer evening. And he came back a week later telling me about it. I've seen a longer daylight in Scotland when I've gone up to Scotland, right? Hence the saying midnight sun. But how do you get a midnight sun on this model here? How do you get 5 months of nighttime and daylight on this model? You've got a lot of explaining to do. You really have. Anyway, that's your homework. That's your homework from Teacher Ron. So I look forward to seeing your reply. I would actually prefer you to actually have the guts and actually make a video and explain it yourself. But anyway, never mind. Whichever floats your boat. Okay, there you are. There we are. Right. So Red Pill Reloaded. Hope you're feeling even more special, because obviously you need to feel special by joining a cult which is useless and has no benefit to mankind whatsoever, has contributed nothing to the benefit of mankind. And I've got to answer this phone. Okay, bye.